Hello and welcome everyone. In this module, we are going to talk about various database services offered by AWS. As you understand, in the IT industry, database has very important role to play. And if you are in databases, you understand that there are various type of use cases. So for example, we have relational databases, we have non-relational databases, we have something called data warehouses, we have in-memory cache, also called in-memory cache data store. So depending on what is your application and what kind of problem your organization is solving, you might be using one or many of these services. So AWS provides a range of these services. Almost for every use case, AWS has got a database service for you. So let's go through these database services from a high level view. We'll go and talk about these database services by taking it one by one in the next few videos. When you click on AWS services, you can go to this database category, and here you can see 4 database related services. So the first service you can see here, RDS. RDS is basically relational database services. So traditionally for transactional databases, we all must have heard about SQL type databases. So this is the most common used databases. These databases consist of tables. The tables have proper schema, which means they would have predefined columns. Every column would have a predefined data type, and there would be multiple rows inside your tables. That's your normal database. Now within the normal database, you might be using different kind of SQL engines. So for example, there is a MySQL engine, which is an open source. Then you have got MS SQL, which is from Microsoft. You have got Oracle, one of the biggest player in the database sectors. So you've got Oracle database engines. You've got some more open source database engines like Postgres, MariaDB, etc. So AWS supports almost all these famous database engines. So in fact, when you go to RDS and start a relational database services, this will give you an option of selecting those database engines. Now you may ask that if I have to run a database, why don't I use an EC2 instance and install a database engine over that EC2 instance? Because that is what we traditionally do. We take a server, we install our database, the software related to database, and we start using our database. Now the difference here is that RDS is basically a platform as a service. You can go ahead and use EC2 instances if you want to go for the traditional ways, and in that case I'll say that you are using infrastructure as a service. But if you are using RDS, you are basically using platform as a service, because here AWS is not only giving you a compute service, it is also giving you inbuilt features for maintaining your database. So for example, it gives you features like taking a backup of your database, and in fact that too automatically. It enables you to restore databases or restore tables. All of this is just few click operation. So if you have been traditionally working in the databases, you must be knowing the role of database administrators. They would be the one who would be responsible for all these activities, and they would be responsible for maintaining your database. They need to understand that how much CPU is getting utilized and how much space is vacant, and so many other type of tasks they will do. Now all that task is now being taken care of by AWS, and that is why we call it platform as a service, not as an infrastructure as a service. This is applicable to other database services as well, which include DynamoDB, Elasticache, as well as Redshift. So all these services are basically platform as a service. You can use them, and most of the things would be managed by AWS. You can concentrate on your logic part. The infrastructure part is basically managed by your AWS. So if you use RDS, you can use Oracle, you can use MS SQL, MariaDB, Postgres, MySQL, etc. Now AWS has also came up with its own database engine, which it calls Amazon Aurora. Now Amazon Aurora is compatible with both MySQL as well as Postgres. So this is Amazon's own database. It has got very high performance. It has got huge scalability and cost effective with respect to other databases. Now since Amazon itself has created this Amazon Aurora, so it is able to give a lot of good features that makes the Amazon Aurora very attractive relational database service. So basically you can create Amazon Aurora, which is MySQL based, as well as you can create Amazon Aurora, which is Postgres compatible. Now that was about your relational databases, or also called SQL type of databases. These databases would be used for storing structured data, the data that will have a definite schema. But nowadays you must have been hearing about NoSQL databases. DynamoDB is a NoSQL database service. Before going into DynamoDB, let's understand why do we need NoSQL databases. Now we understand that relational database services has a very strict schema. So think about a table having a student record. Now while creating the student table, we have to be very sure about how many columns would be there, what would be the data type of each column or field, and then if at any point of time a new student comes and he needs an extra field, so you have to redesign the whole table. You need to either do an add column, which is again very expensive, or you might need to change the schema of the table itself. Now that's a very costly operation in relational database, and that is why we say that relational databases are very strict about the fields that it can have. Now, NoSQL databases gives you an alternative to that. NoSQL databases have a very flexible schema. You don't have to basically tell about what would be the various fields going forward. So we also call this kind of data as semi-structured data. And here we store information in the form of key value pair. So one of the best example of key value pair is JSON format. Now you must have seen the IAM policies by now. Now what are IAM policies? Ultimately this is a document having a lot of key value pair. So the data in JSON files are basically semi-structured, which means they have a pattern of key value pair, but at any point of time you can add a new key value pair. And in fact at any point of time you can use new key in your JSON document. So with the advent of big data, this particular model has become very popular because a lot of applications are generating the data in semi-structured format. So the DynamoDB web service is basically for that kind of use case. So the alternative to DynamoDBs are databases like you've got MongoDB, you've got Cassandra, you've got Cosmos DB in Azure Cloud, and so on. The next service that AWS provides you under the databases is Elastic Cache. Now again, what is Elastic Cache? Elastic Cache is basically in-memory data store. So why do we need it? First of all, in relational database services, the storage space which is being used is basically a disk space. And since disk read and write are costly operations, normally databases has a bit of latency in accessing a particular record or writing a particular record. Now if you're creating an application where you want real-time performance, which means low latency, high throughput, and the use case is similar to databases, then you can use in-memory data stores like Elastic Cache. So there are two very popular open source cache engines. One is called Redis, another is called Memcached. So this Elastic Cache supports both the kind of in-memory data stores. So while creating this service itself, it will ask you which kind of in-memory data store you want. Do you want to go for Redis, or you want to go for Memcached? So it just internally creates clusters and you can create replica of it. It has got very good throughput. It provides very less latency. So if you want to improve and enhance the performance of your application, and if you want to make it highly scalable, this is the service for you. So the next service in the database series is Redshift. Now Redshift, strictly speaking, is not a database. It's basically used as a data warehouse. This is data warehouse as a service. Now Redshift is used for OLAP kind of transactions. So before we talk about Redshift more, let's understand the use case. First, let's understand what is the difference between OLTP and OLAP. Now OLTP means online transaction processing. So OLTP kind of queries are run on transactional databases. And now transactional databases are mostly relational database services. So SQL type of servers would be used mostly for your transactional databases. So just take an example. When you go and purchase a particular stuff from an e-commerce company such as Amazon.com, suppose you are going to buy a shoe, then when you purchase it, a record of your purchase gets saved into a particular database. Now that type of database would be a transactional database. The information would be retrieved if suppose in case you want to return your shoe. So in that case, the transactional database would be read again with something like transaction ID as a primary ID, and all the records of your purchase would be retrieved. That kind of query is called OLTP query. Now let's talk about OLAP. OLAP is basically online analysis processing. So think about this scene. So think about this use case. Let's suppose you are a marketing director at something like Amazon.com. Now Amazon.com is selling the products of Unilever as well as Nestle. And now they want to calculate and compare total revenue of Unilever with Nestle. So to get to the total revenue, they need to scan across hundreds of databases. So each of these databases can be very large. And now if you are going to scan through all the databases, say hundreds of databases for this particular particular one query. So this kind of query which is going to compare, say, the revenue of Unilever and the revenue of Nestle, it is going to be very costly in terms of resources it takes and in terms of time it takes to give you the proper result. So for these kind of use cases, the query that we write, that's called OLAP query. And to run OLAP queries, we don't normally run on the transactional databases. We run it on something called data warehouses. So you can imagine data warehouses as a very large databases. So where you can move the data from hundreds of transactional database and create aggregation of all this data in your data warehouses. And the data warehouse in turn will be using a cluster of compute resources and storage resources so that your OLAP queries can be responded within a limited amount of time. So Redshift is one such data warehouse. So traditionally, you have got Oracle data warehouses, you have got data warehouses from Microsoft, you have got BigQuery from Google Cloud. So Redshift is one of those data warehouses service from Amazon Web Services. So Redshift basically uses a cluster of EC2 instances with a very high amount of RAM and storage space, and it is used for storing and calculating over the data which is on petabyte scale or even exabyte scale. So we'll be talking about these services one by one. So other than your database services, you also have multiple services for associated tasks like database migration. So for that, you have got a tool here under the migration head. So you got database migration service. This will help you to move the data from one kind of databases to another kind of databases, and for moving your data from on-premise servers to the database servers on the cloud. Another few services which are related to database come under this analytics domain. So here you've got AWS Glue, which is basically an ETL tool. ETL stands for extract, transform, and load. You also got Athena, which can query the files which are kept in S3 itself. There are a few offline tools like schema conversion tool that you can download from AWS and use it on your on-premise servers. So we'll talk about these database services in detail in the next few sessions. For this video, this is all I have. Feel free to put your comments in the discussion section and we'll get back to you. See you soon in the next video. Thank you for watching.